Okay, so here's our essential question. What are the key details to remember when solving the 3 different types of equations we solved today? Okay, so we'll solve 3 different types. I described them just a little while ago. And what I want you to think about at the end is each type individually, what are some of the key ideas to remember to help you solve it? Our first example is to solve this equation for x. So 2/3 x minus 1/4 equals 3/5 x plus 1/2. So I have this set up with solution and steps, and we will do a check. Okay, on the test, I will expect you to be able to check your solution. So I told you that we would be able to do this in such a way that we can get rid of the fractions. Okay? So when you're adding and subtracting fractions, what is one of the first steps you have to do before you can add and subtract them? Right? Common denominator. So we can use that idea to help us get rid of the fractions. Okay? So we are going to multiply the entire equation by a common denominator. So you look at all of the denominators. So I have a 3, a 4, a 5, and a 2. Usually I like to start with whichever number is the biggest. Okay? And then we just go through all the multiples until I find a number that all of them can go into. So I love it when it's a 5 because that's pretty easy. 5, 10, 15, 20, 25, 30, 35, 40. Okay, I think we'll have one before we get to 70. So then I look 5. Well, the 2 and the 4 or the 3, none of them go into 5, so that's not going to work. 10. 4 and 3 do not go into 10, so 10 is not going to work. I have to find a number that all of those denominators will go into. 15 divided by 2, that doesn't work. Okay, 15 divided by 2 is 7.5. I want a whole number. 20 divided by 2, that gives me 10, so that one works. 20 divided by 4, that one works, that gives me 5. But I can't divide 20 by 3. Okay, 20 divided by 3 gives me a fraction. So that's not going to work. 25 is not going to work. So none of the 5s are going to work because I have these even numbers, 2 and 4, and they can't go into an odd number value. So cancel those. So 30. 3 goes into 30, but 4 does not. 40. Now it's reversed. 4 goes into 40, but 3 does not. Oops. 50 is not going to work. How about the 60? 3 goes into 60, right? 20 times. How many times does 4 go into 60? 15 times. 5 into 60? 12, right? And 2 into 60, how many times? 30, okay? So 60 is going to work. So we are going to take the entire equation and multiply the whole thing by 60. So it's going to be 60 times the 2/3 x minus 60 times the 1/4 equals 60 times the 3/5. Now you do not necessarily need to do the step that I'm doing right now, but I want to show you what we're doing. Okay, all parts get multiplied by that number, plus 60 times 1/2. And then we're going to simplify this step. So I'm just going to add a little simplify here. So you could go straight from this step to the simplified step. 3 goes into 60 20 times, so that's 40x minus. 4 goes into 60 15 times. Okay. So that's 15 equals 5 goes into 60 12 times. So 12 times 3, 36x. 2 goes into 60 30 times, so plus 30. And now we use our solving procedures to isolate the variable, get x by itself. Okay. So next would be to get the variable on one side. So there's my equal sign. So it doesn't matter which one you do, you just have to be consistent. I usually like to do it so that I get a positive result. So minus 36x on both sides. That gives me 4x minus 15 equals 30. So we'll use some inverse operations to solve. So first, we will add 15 to both sides. So add the 15. Hold on just a second. Add the 15. So that cancels, so you get 4x equals 45. Yeah. All right. So then next, we will divide by 4. So divide by 4 there and there. So x is equal to 45 over 4, which is the same as 11 and 1/4. And then you are going to have to check your solution. Later on, you're going to see why it's absolutely necessary. We have to check. Sometimes it's just checking to see if you got the right answer, but sometimes it's just checking to see if the answer that you got, which was obtained correctly, whether or not it's a real answer. Okay? Because you can get answers, and you did all the work right, but those answers don't work. So it's very important that we always check. So let's go ahead and do our check here real quick. Always check in your original equation. So we're going to have 2/3 times 45 over 4 minus 1/4, 3/5 times 45 over 4 plus 1/2. So all we did is replaced our x's with our answer. And now we'll need to do some simplifying. So in this case, 2 goes into 4 twice. 3 goes into 45. Is that 15? So I try to simplify it as much as I can, although I might need to do some common denominator work later. But try to do some simplifying. So it's 15 over 2 minus 1 over 4 equals 5 will go into 45 9 times. So 3 times 9, yes, 27 over 4 plus 1/2. So we will have to get some common denominators here. So if I times by 2 here, I can get the common denominator of 4. Same thing on this set, if you times by 2 in that last fraction. So we have 30 over 4 minus 1 over 4 equals 27 over 4 plus 2 over 4. So here, 30 minus 1 is 29 over 4. On this side, 27 plus 2 is 29 over 4. I have the exact same thing on both sides, so it works. Notice I worked the left-hand side independent, and I worked the right-hand side independently of each other. Okay? So I just worked down the two sides. Nothing moved. Okay? So I just used order of operations to evaluate this hand side, and order of operations to evaluate that side. Then you compare the numbers at the end. Okay, next example that we're going to look at is solving an expression that has multiple variables and numbers and solve. Okay, so more than one variable. And we're going to solve for one of the variables. So we're going to solve for y. All right, so when solving an equation that has more than one variable, okay, depending on which variable we're trying to solve for, you want to get all of the expressions that have that variable on one side and all the expressions that don't have that variable on the other side. So the terms, the different terms. So I'm solving for y. This piece has a y and this piece has a y. So those two parts have to be on the same side of the equal sign. Right now they're not. And then these two parts do not have a y. So I have to make sure that those parts are on the other side of the equal sign. So we will start by moving the y over. So I'm going to move this xy, and you always use inverse operation since it's a minus in the equation. You're going to add it to both sides. Okay, so on the left, I have a 5x plus xy plus 8y equals, the equal sign doesn't move, 2x, and the minus xy plus xy equals 0. That's why you do the opposite. Now I need to get the 5x to the other side. So I'm going to minus the 5x, minus the 5x. So we have xy plus 8y equals 2x minus 5x. Since those are the exact same variables and there's no other variables with it, you can actually do that subtraction. So 2x minus 5x is negative 3x. Those are like terms. They both have the regular x variable. Now, factor the variable. Think reverse distributive property. What do these two things have in common? A y. So we're going to pull the y out because that's what they have in common. And then you write down what they have left. X plus 8 equals negative 3x. Okay, so I took a y out. What the factoring does is it creates an expression that only has one of the variable that you're trying to solve for. Okay, it's hard if you have two different y's. Okay, we have to get it together so we only have one y. So we can get y equals a whole bunch of stuff. Okay. So the y is now by itself. We're going to solve the rest of the equation. So how do I get rid of this x plus 8? All right, this is multiply y times this stuff. So we divide by that stuff because that's the opposite of multiply. Divide. And so that cancels, leaving the y all by itself because we want to get the y by itself. And your answer is negative 3x over x plus 8. That's your answer. That's all you can do. You cannot do anything else. There is no more simplifying. Anything else you try to do with that expression would be illegal. Okay? So we're going to solve and check our solution for absolute value 2x minus 3 equal to 5. So remember the problems that we were looking at on the Explore section? How many answers did we have? 2. We had 2 answers each time, right? So when we solve this, we're going to have 2 equations that we need to solve. So you take the stuff that's inside the absolute value. Take it out. That's the part that is either equal to a positive 5 or that part is equal to a negative 5. Okay, so you have to set up your 2 equations. Set up 2 equations. Okay, because we have a positive case and a negative case. Solve each equation. Once you get that set up, you just solve. Note, are there any absolute values on that step? No. If I see absolute values in that step, you lose points. Okay? There are no absolute values when you split it up. If I put an absolute value here, okay, it's no solution. That doesn't make sense. Okay? So when we split them up, what we're doing is we're taking the stuff on the inside. Okay, inside the absolute value, and we're just taking that piece, and that's the part that's positive or negative. Okay, so we're taking that out, get our positives and negatives. Now we solve. So add 3, 2x equals 8, divide by 2, x equals 4. Or the other side, add 3. Okay, so on the other side, we're adding 3 to both sides. Now remember, it was a negative 5 over there. So now it's 2x equals negative 2. Because negative 5 plus 3. Divide by 2, x equals negative 1. Okay, and then we want to check our solution. So you have to check them separately. You have 2 parts. So check the x equal to 4 piece, and then we'll check the x equal to negative 1 piece. So x equals to 4. Start with your equation. 2x minus 3 equals 5. Absolute value, the 4 becomes the x. So 2 times 4 minus 3 equals 5. So we're checking to see if it equals 5 or not. So you're going to evaluate the left-hand side all by itself. So multiply first. We haven't done anything with the absolute value yet, so you can't get rid of it yet. 2 times 4 is 8, minus 3. 8 minus 3 inside the absolute value. Still haven't done anything with it yet. Now, what's the absolute value of 5? 5. So 5 equal to 5 works. Okay. Now we'll do the negative 1. 2 times negative 1 minus 3 equals 5. So inside, do the multiply. 2 times negative 1 is negative 2, minus 3. Equals 5, so we don't know if that's true yet. Negative 2 minus 3 is what? Negative 5 equal to 5. What is the absolute value of negative 5? 5. 5 equals 5, so it works. Okay. So 4 and -1 are both possible solutions. Yes? The only thing I wanted to say real quick, if you have a problem like this, note that anything outside the absolute values, you have to get rid of those first. Okay, so I would have to -1 first, get x plus 4 equal to 8, then split it up into the 2 separate cases. Okay? And if there's a number in front here, that means divide by 2. So I'd have to divide by 2. So if I had a 2 in front here, divide both sides by 2. Then split it up into the 2 cases. Okay? Does that make sense? Okay, so get rid of the stuff on the outside first, then do your 2 cases.